Started. Okay. For today, we will discuss about moment and couple. So this is our first topic. Actually, it's not just moment and couple, but force as well. Okay, this is our first topic, and for this particular topic, we will start with Newton's law. Okay, we will start with Newton's law. I think I will ask some of you. Audrey Putri. Audrey Putri?
Yes, sir.
Okay. Do you remember what is the first Newton law, Audrey?
Yes.
What is the first Newton law?
Is it the one that when
Hey,
body
don't
is
forget to
still-
turn on your camera. Remember the,
Oh, yeah.
my class rules. Okay. What is the first Newton law?
Is it the one that says when a body is at equilibrium, it will stay in equilibrium,
If
and if there's no force acting on it?
okay. So if one thing, if a thing has no force acting on it, okay, it will stay in equilibrium if the initial state is equilibrium, and it will, if the initial stage is the thing is moving, what will happen then?
If it's moving in constant speed, it will continue moving in constant speed if there's no force acting on it.
So when one thing is the initial state of one thing is in moving condition, then it will move in constant speed. So that's the first Newton law. Okay. Thank you, Audrey. When we talk about statics, okay, most of the time we will talk about the first Newton law and the third Newton law. Okay, but I want to check whether you still remember the second Newton law as well. Okay, the next one will be Wildan Akmal.
Yes, sir.
Okay, Wildan. What is the second Newton law?
Is if I'm not wrong, was the force acting on an object is equal to the mass of the object times its acceleration.
Okay, so it's F equal to m multiplied by a, right? That's the second Newton. That's the second Newton's law. Okay, thank you, Wildan.
Yes, sir.
The second Newton's law, most of the time we don't use it in our statics class because we are talking about statics. We are talking about something that is not moving. We are not normally talking about the second Newton's law. Okay, but as I told you, most of the time we will use the first and the third Newton's law. And next, Diva Dwi Cahyo.
Yes, sir.
Okay, I want to check whether you remember the third Newton law.
I think it's the every action gives action, and if you give force to some things, I kind of forgot.
So actually, the easiest way to explain that Newton law is action and reaction. Okay? So whenever you give an action certain force to something, you will get the same force but in the opposite direction. Okay, it's action and reaction. That's the third Newton law. Okay, Diva. So if I can
Yes.
explain it in the picture, you can see that if you put a mass on top of a ground like that, this is for example a box like that. Okay, if you take a look at the box, okay, the box actually is giving a force his weight force downwards towards the ground. Okay. At the same time, the ground giving a reaction force to the box, the opposite reaction force, and the value of the magnitude of the reaction force is the same as the action force which the box gives to the ground, like that. Okay, bisa ditangkap ya, Diva ya?
Yes, yes.
Jadi hukum Newton ketiga itu aksi reaksi, ya. Saat kita memiliki kasus seperti ini, ya, kotaknya itu memiliki massa tertentu, memiliki berat tertentu, memberikan gaya ke bawah sebesar beratnya ke ground. Nah, di saat yang bersamaan, ground itu memberikan gaya berlawanan arah, gaya reaksi berlawanan arah dari ground ke box-nya dengan besar yang sama persis dengan gaya aksi. Oke, aksi reaksi itu adalah hukum Newton yang ketiga. Okay, so basically, when we talk about statics, we will keep talking about the first Newton law, and we will keep talking as well about the third Newton law, because those two is the main basic, the basic of statics. Okay. Then next, I want to discuss about moment. Okay. Anyone here remember what is moment? Randy, hello Randy. Chai sa Randy, right? Randy, right?
Yes, sir.
Okay, Randy. Do you remember what is moment?
I think it's related to inertia. I think.
No. Yeah.
Hello.
When you talk about moment inertia, it's about the rotational movement, right? So, but basically, moment is not just related to inertia. Okay, when moment is not when moment is not causing a rotational movement, okay, it has no relation with inertia. Okay. Okay, I will check with the other then. Timothy Nicholas.
Yes.
Hello,
Yes,
Timothy.
sir. Yes.
Do you remember what is moment, Timothy?
I think moment is like the turning effect caused by force.
Turning effect caused by force. Okay. And what will affect the magnitude of a moment? Timothy.
Mm,
I'm giving
the
you
distance,
the
maybe.
equation there, right?
Yeah. The distance
The distance, what else? There are two
and the
things
amount of
which-
force.
Yeah, correct. So when we talk about moment, okay, there are two things which will affect the magnitude of the moment. The first one is the magnitude of the force itself, and the second one is the distance of the force from the center of rotation. Okay, so you guys can see this particular picture. Okay, when we have a force F and with certain distance from the center of rotation A, like that, okay, the force F will create a moment at center of rotation A, and the magnitude of the moment is R cross F. Why we are using cross here? Because force is a vector. Okay, R is the distance vector from center of rotation to the force F, and the moment as well is a vector. So when we talk about a vector, order to produce a vector from multiplication of two vectors, we have to use cross, and that is what is happening here. So when we talk about a moment, okay, moment is actually the cross product between r, the distance vector from the center of rotation to the force, okay, to the location of the force, and the force vector itself. So r cross f. Jadi kalau kita membicarakan terkait dengan momen, momen itu adalah produk cross product ya, perkalian cross antara dua hal. Yang pertama itu adalah vektor jarak ya, vektor jarak dari center of rotation, dari pusat perputaran A ke gayanya, oke, dicrosskan dengan gayanya itu sendiri, vektor gayanya itu sendiri. Oke, jadi definisinya seperti itu. So the definition is like r cross f. Okay, using this r cross f, we can try to simplify it to the scalar form. Okay, if we just want to find out the magnitude of the moment, then we can try to simplify it to the scalar magnitude, into the scalar form. Okay, the scalar way to calculate the moment is force multiplied by the perpendicular distance between the force and the center of rotation. Jadi kalau untuk mendapatkan momen ya, untuk mendapatkan momen, kita bisa melakukan simplifikasi terhadap persamaan utama ini ya, r cross f, itu bisa kita lakukan simplifikasi untuk hanya mengetahui besarnya saja ya. Kalau besarnya saja kita bisa melakukan perkalian skalar. Perkalian skalarnya itu paling gampang adalah gaya, besar gaya ya, dikalikan dengan jarak tegak lurus antara gaya dengan center of rotation. Seperti itu. Okay. About these basic concepts, anyone here want to ask question about this? Seharusnya cukup mudah ya. Jadi it's actually quite simple, I believe, because it's something that you learn in the high school. So moment is equal to r cross f. That's the basic principle. But if you just want to find out the magnitude, you can use the scalar form, the magnitude of the force multiplied by the perpendicular distance between the force and the center of rotation. Okay. So if you take a look at this, right? When I want to calculate it using a vector form, okay, you are not necessarily to have this vector, this distance vector, as the perpendicular distance. So you don't have to use, sorry, you don't have to use this as your distance vector r. Okay, you can use any distance vector which connect the center of rotation and the force vector. So your distance vector can be this r, okay, or you can use this one as well, or you can use this one as r, as long as it connects the center of rotation and the line of the vector, like that. Okay, so because it's a cross product, actually you can choose whatever you like as the r, as long as it's connected between the center of rotation and the line of flow of the vector. Okay, but if you want to calculate it using scalar form, okay, the easiest way to calculate it is by multiplying the magnitude of the vector f, only the magnitude, okay, and the perpendicular distance t. That's what you normally learn in the high school, okay. f multiplied by d. But it's a scalar multiplication because we just want to find out the magnitude of the moment. Okay, one more thing. If you have a problem in understanding about something that I explain, that I'm currently explaining, okay, please interrupt. Please, you can try to interrupt me directly by turning on your mic and asking questions. Okay, I don't have problem with that. Okay. I think it's easiest for you guys to understand it deeper by finding this particular problem. Okay, we have this problem. Okay, it's something kind of it's some kind of pillar with a certain extension like this, and there is a force 600 Newton force working at point A. Okay, and you are asked to calculate the magnitude of the moment at point O. Okay, at point O, like that. In 5 different ways. Is you don't have to do it. Just try to calculate it using either the cross product or the perpendicular distance. Okay, anyone here want to try to do this? If no one volunteer, then I will point out. I will point somebody to do this. Hello? Anyone want to volunteer? No one. In that case, I will ask Safran. Safran Ahmad. Would you mind to help me to calculate this, Safran?
Yes, sir.
Okay, how to do this? How to calculate for the moment which is caused by 600 Newton force at point A, due to 600 Newton force at point A. Okay, the moment that we want to calculate is the moment at point O, with O as the center of rotation. How to do this, Safran?
So first, I think we should find the distance between the point O and point A.
The distance. Okay.
Yes,
What is the distance between those two?
I think we can use the Pythagoras.
Okay. So you want to use Pythagoras to find this distance, okay? And then after that, after that, what should we do, Safran? Your mic is off. Yeah.
Sorry, sir. We can calculate by crossing F and at the force and the distance.
Simple multiplication or cross product?
The simple
Multiplication. In that case,
Yes.
there is a slight problem, Zafran, because OA is not necessarily perpendicular to the force, Zafran. If you want to use simple multiplication, then you have to use the perpendicular distance, right? F multiplied by D, right? Correct or not, Zafran?
Yes, correct.
Yeah, but unfortunately, the angle here is not 90 degrees. Okay, so you can use simple multiplication there. Okay, Sabra. Do you want to point out somebody else to help you to finish this?
Yes, sir. I think you can choose anyone, sir.
I want you to point out somebody else to help you to do this, which you think can help you to finish this.
Okay, Fauzan, sir.
Fauzan. Hello, Fauzan. Safran, you still have to be there, Safran.
Okay.
Hello, Fauzan. Fauzan, are you there? Where is Fauzan? Fauzan is not responsive. I believe you're supposed to find somebody else, Safran.
Okay. I think.
Safran?
Yes, sir.
Huh?
Shan, maybe Shan.
Shan. Hello, Shan.
Yes, sir.
Fauzan is on.
Hello, sir. Sorry, I blacked out.
What happened to you, Fauzan?
No, connection problem. Maybe.
Okay. Fauzan, Safran asked you to help him to finish this. Safran wants to use d f multiplied by d, but d is perpendicular distance. How can we find the perpendicular distance? Fauzan.
Wait.
Any idea, Fauzan?
No idea, sir.
No idea. Anyone here can help Safran and Fauzan to find the perpendicular distance or to finish this particular problem? San, how about you, San?
Yes, sir.
How?
I'm guessing we need to project it first, sir.
Project it. Which one that we need to project?
The force in A. We project it towards the x-axis, maybe.
You mean like this? You mean like this? Like this?
Yeah, is that possible, sir?
Then after that, what should we do there after we project it like that?
No, I mean, so the force we multiplied by cos 40 and then just times the distance, which the 2 square root of 5.
You mean like this? The force, you find the horizontal. You try to find the horizontal component of the force. You mean like this? So you multiply the 600 Newton with cos 40, and then after that, you can multiply that particular projected force with the vertical distance, right? That's what you mean.
Yeah, is that possible, sir?
Yes, that one is possible.
Okay.
Okay. Wait a minute. That one is possible, but it's not necessarily correct because there are the projection. We have two projections, right? The first one is the vertical one. The first one is the horizontal one, and the second one we have the vertical one. Right? The horizontal one will cause a moment after we multiply the horizontal force with 4 meters, the vertical distance. And the vertical force here, it will cause moment as well by multiplying with 2 meters. Right? Okay. This one I will discuss it later in the Ferdinand theorem. So, but for the current one, I want to calculate. I want you to calculate using using the things that I already explained to you before. This one, either R cross F or F multiplied by T. Do you have any idea on how to solve that? Shan?
No idea, sir. Sorry.
No idea. So let's us discuss about it. Okay. But your idea is not absolutely wrong, okay, Shan? Because we can use the force projection there, of course. But we have to do it for both the vertical and the horizontal one. Okay. Clear my drawing. Okay. So this is the way on how we can do the can find the perpendicular distance. Okay, so basically, if we have a 40 degrees here, okay, if we have a 40 degrees here, we can try to find the perpendicular distance by creating another 40 degrees here from here. Because if we do this particular line and this angle is 40 degrees, okay, we will find that this particular angle will be 90 degrees. Correct, right? So basically what we're supposed to find is the D here. The distance between O to force here, okay, but the perpendicular distance. Then how to find out the value of D? Okay, how to find out the value of D? That's the question, right? Okay, how to find out the value of D? Then we can divide it into two, where this division is perpendicular. So this particular line is perpendicular as well. There, okay. By using the first triangle, by using that particular triangle, okay, we can find out this particular line, right? Okay, we can find out that particular line because we have 4 meters there and we have the angle there. Correct or not, Fauzan, Safran, and Sam?
Yes, sir.
Yeah, we have 4 meters here. We have 40 degrees angle here. Okay, using these two values, of course, we will be able to find out this particular line. Okay, how to find it? Then 4 meters is the 4 meter is di sisi miringnya ya, bagian miringnya itu. Jadi, so we can find this particular distance using 4 meters cos 40 degrees, right? Correct, right? 4 meter cos 40 degrees is this particular line. Okay, that's the first one. Okay, and now the second one, this one. Okay, for that one, the second length will be the same as this particular length. Will be the same as this particular line. So we can see this particular triangle actually. Okay, if we see that particular triangle, we have 2 meters there. Okay, and we can we know that the angle here is 40 degrees. This angle here will be 40 degrees as well. So this particular length, okay, will be 2 meters sin 40 degrees. Because we have 2 meters, yeah, okay, and 40 degrees here. So this the second line, this one is D1, this one is D2. D1 will be 4 meters cos 40 degrees. D2 will be 2 meters sin 40 degrees. So in total, we will have the total D. Do you get it, Fauzan, Safran, and Shan? Okay, good.
Yes, sir.
So that's the perpendicular distance. If we already get the perpendicular distance, then it's simple. In order to find out the moment at point O due to force 600 Newton, then we can multiply the force, the magnitude of the force 600 Newton with the perpendicular distance. Perpendicular distance is 4.35, right? Based on this calculation, then we can calculate that the moment is 600 Newton multiplied by 4.35 meters. So in total, the moment will be 2,610 Newton meter. Okay, that's the way of doing that using perpendicular distance. Oke, jadi ini caranya untuk mencari momen dengan jarak tegak lurus, gitu ya. Kita cari terlebih dahulu jarak tegak lurusnya. Caranya bagaimana? Kita bagi dua. Kita dapat setelah kita bagi dua tegak lurus itu, kita dapat dari segitiga pertama 4 meter cos 40 derajat itu D1. Lalu dari segitiga yang kedua di sini 2 meter sin 40 derajat adalah D2. D1 ditambah D2 itu jadi panjang tegak lurusnya 4,35 meter. 600 Newton dikali 4,35 meter itu hasilnya akan jadi momennya 2.610 Newton meter. Okay. So that's one way of doing that. We can calculate it using vector as well. Okay. Okay, we can calculate it using vectors as well. So if you want to calculate it using vectors, then you have to find the distance in vector, and then multiply it with the and then make it as cross product with the force in vector as well. Okay, so we can do it that way. But for the vector, I don't think that I will discuss it today. Okay, the next one is the one that San talked about. Okay, the next one is the one that Shan talks about. Okay, when we have a certain force, okay, R like that. Okay, we can divide the force into several forces, where if we add those several forces, the summation will be the same as the R. Okay, we call this theorem as a Farignan theorem, and when we divide this vector R into vector P and Q, okay, where vector P plus vector Q is equal to vector R. Okay, so basically, if you want to divide vector R into P and Q, we can do it that way. Okay, so if we want to calculate the moment which is caused by vector R, okay, we can calculate it by adding the moment which is caused by vector P, okay, and the moment which is caused by vector Q. So basically, if we want to find out the effect of vector R, if we want to find out the moment which is caused by vector R at O, okay, we can do it by dividing vector R into P and Q, and then calculating the moment which is caused by vector P at O, and the moment which is caused by vector Q at O, and then sum it together. So basically, yeah, if we know that the perpendicular distance of vector R to point O is P, then the moment which is caused by vector R at point O will be R multiplied by D. Okay. And if we know as well the perpendicular distance of vector P at point from point O is small p, right? And the perpendicular distance of vector Q will be Q here. Okay. Then, and we know that the summation of both, one will give a positive moment and the other one will be giving a negative moment. If we think, if we use clockwise as a positive moment, then vector Q here will give you a positive moment. So Q multiplied by Q will be positive and P multiplied by P will be negative. So both is actually the summation of the moment, right? The summation of moment which is caused by P and Q. It will be the same as the moment which is caused by vector R. So that's a Falkner theorem. Okay. So basically, if you divide the force into its component, then the moment which is caused by the summation of the moment which is caused by each component will be the same as the moment which is caused by the main force. Jadi, ini kalau saya jelaskan dalam bahasa Indonesia ya, Falkner theorem itu menjelaskan bahwa saat kita mempunyai suatu gaya tersebut bisa dibagi menjadi komponen-komponennya. Misalkan dalam kasus ini ada gaya R, itu bisa kita bagi menjadi gaya QP dan juga gaya Q. Okay. Momen yang disebabkan oleh vektor R terhadap titik O, itu nilainya akan sama saja dengan penjumlahan momen akibat gaya P di titik O dan juga momen yang diakibatkan oleh gaya Q di titik O. Seperti itu. Ini sebagai contoh, ya. Jadi R multiplied by D itu adalah momen akibat vektor R, gaya R. Lalu komponen-komponennya adalah P dan Q. Kita hitung momennya masing-masing. Momen akibat Q itu adalah Q multiplied by Q dikalikan Q, positif. Momen akibat P itu adalah P dikalikan P, negatif. Totalnya itu akan sama dengan R dikalikan D. Seperti itu. Itu adalah Falkner theorem. Seperti itu ya. Jadi gaya-gaya akibat komponen momen akibat komponen gaya, total momen akibat komponen-komponen gaya itu akan sama dengan momen yang diakibatkan oleh gaya sebelum dibagi menjadi komponen-komponennya. Seperti itu. Okay. In order to make it clearer, I think I will try to use exactly the same problem. Okay, but we will try to solve this using Falkner theorem. Okay, San, because you are the one who give this idea. Okay, would you mind to help me to divide the vector 600 Newton vector into its component? Sure.
Yes, sir. I've actually calculated the moment. So
the horizontal component is supposed to be what is the value of the horizontal component? Sure.
600 cos 40.
Correct. 600 Newton cos 40 degrees will be the horizontal component of the vector 600 Newton. Okay. And then the vertical component will be
600 sin 40.
sin 40 downwards. Okay.
Yeah.
600 Newton sin 40 degrees. Okay. And then, okay, the value of the moment. Okay, the value of the moment we have calculated before. If we calculate it using the perpendicular distance of the 600 Newton, the value of the moment is 3,600 something. Sorry, 2,610. It's 600 multiplied by 4.35 meters. Okay, let's try to do the same, but using Ferrickson theorem. So just now we have 600 Newton cos 40 degrees as the horizontal one, multiplied by the perpendicular distance. What is the perpendicular distance of the horizontal component?
Force.
The perpendicular distance is, what is the perpendicular distance of the horizontal
4.
component? 4 meters, correct?
Yeah.
4 meters is the perpendicular distance. So 600 Newton multiplied by cos 40 degrees multiplied by 4 meter. Okay, it will be our first moment component, our first force moment, like that. And then due to the vertical one is 600 Newton sin 40 degrees. What is the perpendicular distance there?
2 meters.
2 meters. Okay, perpendicular distance between point O to the force. Remember, okay, the perpendicular distance between the point, the center of rotation with the force. So it's 2 meters. So 600 newtons multiplied by sin 40 degrees multiplied by 2 meters. That's the second moment component. Okay, you sum it together, the result is supposed to be the same as 2,610. Let's check. Okay, it's like this, right? 600 Newton, we divide it into two components. F1 is the horizontal one, 600 cos 40 degrees. F2 is the vertical one, 600 sin 40 degrees. The perpendicular distance of the horizontal force is 4 meters. The perpendicular distance of the vertical force from point O to the vertical force is 2 meters. From the point O to the horizontal force, it will be 4 meters. Okay, that's why we get this result. The first moment will be 460 multiplied by 4 meters. And the second moment will be 386 multiplied by 2 meters. The total will be the same, 2,610. Okay, remember, when after you divide it into its component, okay, in this case, we already divide 600 Newton into F1 and F2. F1 is the horizontal component, 600 Newton cos 40 degrees. Okay, the things after that, we have to find out the perpendicular distance from the center of rotation to the force. So this is the perpendicular distance, 4 meters. Okay, and then we also need to find out the perpendicular distance of F2. The perpendicular distance of F2, right? It will be 2 meters. From O, okay, from O to F2, it will be 2 meters. That's why the first moment will be 460, 600 cos 40 multiplied, and 600 cos 40 is 460 Newton, multiplied by 4 meters. And the second moment will be 386, which is come from this 600 Newton sin 40 degrees, okay, multiplied by 2 meters, because the perpendicular distance here is 2 meters. The total will be the same. So this is Ferrickson theorem. Okay. Anyone want to ask question about this? Jadi metode kedua kita adalah dengan metode Ferrickson, ya. Metode Ferrickson itu intinya adalah kita bisa membagi gaya menjadi komponen-komponennya. Momennya pun itu penjumlahan momen akibat komponen gayanya. Ya, dalam kasus ini kita punya gaya 600 Newton, kita bisa bagi menjadi komponen horizontal dan komponen vertikal. Komponen horizontal adalah F1, 600 cos 40 derajat. Komponen vertikalnya adalah F2, 600 sin 40 derajat. Oke. Lalu kemudian setelah kita bagi menjadi komponen-komponennya, masing-masing komponen kita coba cari jarak tegak lurus ya terhadap pusat perputaran. Pusat perputaran itu O ya. Yang ditanyakan adalah pusat perputarannya O. Jarak tegak lurus dari O ke F1 itu adalah 4 meter, ya. Karena ini kita bisa perpanjang garis kerja gayanya. Ini adalah jarak per tegak lurusnya, 4 meter. Lalu jarak tegak lurus dari dari O ke F2 itu adalah 2 meter. Jadi momen akibat F1 itu adalah 600 Newton kali cos 40 dikalikan dengan jarak tegak lurus 4 meter. 600 cos 40 kali 4 meter. Kemudian momen akibat F2 itu adalah 600 kali sin 40 derajat, oke, dikalikan dengan jarak tegak lurus 2. Total momennya akan sama saja, 2610. Sama dengan yang kita sudah hitung sebelumnya, 600 Newton dikalikan langsung dengan jarak tegak lurus 600 Newton ke titik O. Seperti itu. Oke. Until this point, anyone want to ask question? Safran, do you understand, Safran?
Yes, sir.
Okay, good. How about you, Fuzan?
Understood, sir.
Good. Rehan Novel, apakah dipahami, Rehan?
Yes, sir.
Nah, sip. Bagus. Oke. Jika ada yang masih belum paham, silahkan langsung ditanyakan. Okay. For those who still a bit confused about this, you can directly ask question to me for this. I believe it's clear enough. Okay. This is how can we calculate the moment using Farikhan theorem. And remember, most of the time, it will be easier for us. Okay, it will be easier for us to calculate the moment of certain force using Farikhan theorem. Okay, because most of the time it will be easier as well to find out the perpendicular distance of the force component instead of the force itself. So for example, like this, finding the perpendicular distance of 600 Newton, it is harder. It is way harder than finding the perpendicular distance of the F1 and F2. Okay, as what we discussed here, okay, finding the perpendicular distance of the 600 Newton it's quite a lot of geometric calculation there. Okay, so sometimes it will be way more difficult to find out directly the perpendicular distance of the original force. And most of the time, it will be easier for us to divide the force into its component and finding the perpendicular distance of each component. Okay, so Farikhan theorem, it's how to say that? Farikhan theorem is it's very useful in calculating the moment value. Okay, and it is easier as well if you divide the component into the perpendicular component. Okay, so for example, we have the 600 Newton, so it will be easier to divide it into the horizontal component and vertical component. Don't use the other one. Don't use the other component, because if we use a non-perpendicular one, it will be harder as well to find the perpendicular distance. Okay, I believe it's supposed to be understood clearly by you guys, right? Yeah. Okay, next one. Next, this will be our last thing to be this. It will be the last thing that I will discuss today. It's about couple. Okay, couple. What is couple? Okay, wait. I think I will ask some of you then. Amadea, I believe yesterday they already asked. Zakia. Halo Zakia. Apa itu couple, Zakia?
System of force with a resultant moment but no resultant force.
Pintar membaca kamu ya. Okay, so terima kasih banyak Zakia ya. So actually, what you see here, couple is actually it's like a please differentiate this couple with couple or human couple. Okay, the things that what we mean by couple here is a forced couple. Okay, forced couple. When we talk about forced couple is a two forces which has exactly the same magnitude but with opposite direction to each other. So if we have two forces and each of those having the same magnitude, tetapi but the direction is opposite to each other, then we can call it as couple. Jadi couple itu kalau dalam penjelasan dalam bahasa Indonesia adalah yang kita maksudkan dengan couple di sini adalah couple gaya. Oke, saat kita membicarakan couple gaya, artinya itu apa? Artinya dua gaya yang besarnya sama persis, tetapi arahnya berlawanan. Saat kita memiliki dua gaya yang besarnya sama persis dan arahnya berlawanan, kita sebut dia sebagai couple. Couple gaya, seperti itu. Okay. What is so special about this force couple? Okay, let's try to calculate it each other. The last one that I asked to answer my question is Satya. Satya, would you mind to point out the point somebody here to answer my question, Satya? Tunjuk satu orang di sini untuk menjawab pertanyaan saya.
Fatima.
Fatima. Ya, oke. Halo Fatima.
Hello, sir.
Halo Fatima. I want you to try to calculate the moment which is caused by this couple at point O. Okay. Try to calculate. So we have F here. We have minus F here. We have F here. What is the moment which is caused by both of these forces at point O? What is the total forces? Sorry, the total moment due to both of these forces at point O. Fatima. Maybe you can calculate one by one due to these forces, this force. What is the moment which is caused? What is the value of the moment which is caused by that force at point O? Moment is the multiplication of the magnitude of the force with the perpendicular distance, right? Correct, right, Fatima?
Yeah.
Assume that the magnitude is F. The magnitude of the force is F, and the distance from O to this particular force is A, and from this particular force to this particular force is D. What is the magnitude of the force? F, right?
Yeah.
Okay, and what is the distance between O and F?
Do we need to add A and B?
Yes, of course.
Like
Right.
A plus
A plus B. Yep. That's the moment due to F, right? And the moment is supposed to be counterclockwise, right, Fatima?
yeah.
Counterclockwise, like this. Okay. Now, how about the moment, this particular force then? What is the moment caused by that particular force? The magnitude is the same, right? F multiplied by the distance. What is the distance between that force with O?
Is it only A?
Yes, correct. A. But remember, now the direction of the moment is clockwise, right?
Yeah.
Yeah. So if we want to sum both, right? Okay, because this one is counterclockwise and this one is clockwise. Okay, we have to minus the first one with the second one, right? Because the direction is different, correct? Right?
Yes.
Yeah. So what is the total force? Sorry, the total moment. F multiplied by A plus B minus F plus A. What's that? What's the total? It's simple, right, Fatima?
Yeah.
F multiplied by what?
F A.
If you are
Is it
confused,
only F D?
yes, of course, it's FD, correct. Because this one is FA plus FD, right? You can divide it like that, and then minus FA. So what we get is only FD. Okay. So this is the moment which is caused by both forces, right, Fatima?
Yes.
Okay, now, Fatima, I want you to point somebody else to answer my question, my next question.
Yeah.
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 Okay, Dia. Ama Dia, I believe, right?
Yes.
Okay, Amadia. Would you mind to turn on your camera, Amadia?
It's on.
Okay. Yeah, now the same question as the question to Fatima just now, but I want you to calculate the moment which is caused by both forces, but towards point, the center of rotation is not O anymore, but this one, this point. What is the moment which is caused by both forces at that particular point? Yeah.
In that case, does it mean that we can just neglect A, distance A?
Oh, yes, of course, you can neglect distance A. And you can calculate one by one the moment due to F and the moment due to minus F. What is the moment due to minus F at that particular point? Yeah.
I think it's just 0 because there's no distance.
Yes, correct. Because there is no perpendicular distance. That's why the moment due to minus F is 0. How about the moment due to F? Yeah.
FD.
FD, correct. Clockwise or counterclockwise?
Counterclockwise.
Counterclockwise, the same as this one. Exactly the same as the first one. which calculated by Fatima just now, right? Yeah.
Yes.
Okay. Now, still, yeah, the last one. Actually, this is the last question for everyone. Now, try to calculate the moment due to both. Okay, at point at this particular point. The moment due to force F. What is the moment due to force F at that particular point? Yeah.
Negative F A.
Huh? No.
Wait.
Due to F. Due to F at this particular point.
Oh, just F times AD. F times A plus D.
Okay. The point is here.
Oh no, it's 0. It's 0.
0, correct. So the moment due to F at this particular point, right? It will be 0, right? And the moment due to minus F will be what? The distance is what? The perpendicular distance is what?
Also 0.
No.
Oh no,
Okay.
it's
The perpendicular distance. Negative F multiplied D, right? Not A plus D, right? The force is here. The point is here. So the perpendicular distance is supposed to be this one.
Yeah, it's just. Oh yeah.
Okay. So whenever you guys want to calculate the moment due to certain force at certain point, okay, try to find the magnitude. Try to find the perpendicular distance. As simple as that. There. Okay. The perpendicular distance between the minus F and point, this particular point, is D, right? Yeah.
Yeah, I was a bit confused because I was looking at the point where negative F is pointing at.
Ah, okay. Yep. So, so this is the point. Negative F will create F multiplied by D again, right? For the moment, right? And the positive F will create 0 moment. Okay. And the direction for the negative F will be counterclockwise as well, right? Correct or not? Yeah.
Yes.
Yeah. So you can see, okay, this one is the moment which is caused by both forces at point O. This one is the moment which is caused by both forces at this particular point. Maybe we can call it as O1. Okay? And this one is the moment which is caused by both forces at point O2. Okay. Can you conclude here? What is so special about couple? Hello there. Can you conclude there?
Sorry.
Can you conclude? So you can see, right, at point O, the moment which is caused by both forces is F multiplied by D counterclockwise. At point O1, both forces will create moment F multiplied by D counterclockwise as well. At point O2, both forces will create F multiplied by D counterclockwise as well. Right? So basically, okay, if we are talking about couple like this, okay, wherever the center of rotation is, the moment which is caused by both forces will be exactly the same. That is what is special. That is what's special about couple. Yeah. Do you understand? Yeah.
Okay, you're saying if the direction is the same, no matter where the point is, the couple is the same.
The moment will be the same. The moment which is caused by a certain couple will be the same. So, for example, if we have this couple, right? Okay, the moment which is caused by this couple at this particular point, this particular point, this particular point, or any other point will be exactly the same. And the moment will be F multiplied by D, where D is the distance between both forces. Perpendicular distance between both forces. You get it ya?
Yes, I get it.
Ya.
Sir.
Ini terakhir dalam bahasa Indonesia saya jelaskan. Jadi apa spesialnya? Couple itu adalah gaya, dua gaya dengan nilai yang sama tapi berlawanan arah. Oke, yang spesial adalah kalau kita mempunyai suatu couple, dimanapun titik perputarannya, pusat perputarannya dimanapun, itu nilai momen yang akan diakibatkan oleh couple tersebut akan sama persis. Nilai momennya itu akan sama dengan gaya dikalikan D. D itu adalah jarak tegak lurus antara kedua gaya tersebut. Seperti itu. Oke, I think that's all for today. Tomorrow we will meet again at 7 in the morning. So please try your best to wake up early tomorrow. We will have a 1-hour class tomorrow from 7 to 8 in the morning. Okay, thank you very much for listening. See you guys tomorrow. Bye.
Thank you, sir.
Yes, sir.
Yeah.
Good night.
Thank you, sir.
Thank you, sir.
Okay. Bye bye.